Cool. I think we can start. Um, Good evening, everyone. Welcome to the 72nd Geek Night of Hyderabad. Those who are joining for the first time, Geek Night is just a session where we talk anything that normally geeks talks about software technology, about new things that we work on and would like to share with everyone. So today we have two of our thought workers sharing an interesting topic, which is, as you can see, data mesh implementation with Google Cloud. So I think without further ado, we can start. So I will ask the speakers to introduce themselves. Murli, you can start, maybe.
Yep. Thank you, Sanket. So good evening, everyone. Thank you all for joining session today. So before getting into the session, I'll introduce myself. I'm a lead consultant with ThoughtWorks, and I have over 20 years of experience in IT industry, mostly worked on architecting and building distributed systems in my experience. Currently in data space, helping organizations to become data-driven. And I'm also a data mesh practitioner, and I am holding currently Google Cloud Certified Data Engineer certification and also AWS Certified Solution Architect Associate. Here with me, I have one more speaker, Bala. I would like him to introduce himself. You're on mute, Bala.
Can you hear me now? Yeah. Okay. Hey, hi everyone. So I'm Bala. So I have totally like 8 years of experience like in IT industry. So basically I have like a solid experience in Java and Clojure, but I have hands-on experience with Golang and Python. Also, like I have worked in like both like product development and SaaS development, shippable product. And I have like good experience in AWS and GCP platform services, various services. So currently, like I'm working in like in a data mesh platform project where I'm one of the platform engineers who build this like a data mesh platform for one of our client. So over to you, Murli.
Thank you, Bala. So today the topic is how to build data mesh in Google Cloud. So before getting into the actual topic, let's try to understand what is data mesh and why do we need. So for that, let's try to understand some context. So there is an independent organization which kind of does survey on organizations which wants to uh, become data-driven organizations. That is New Wanted survey. So based on the survey, it shows that there are organizations interested in becoming data-driven organizations, and they have been investing huge amount on these investments like big data and AI initiatives. So here it shows that from 2018 to 2021, there is an increase of organizations which invest minimum of $500 million in big data and AI initiatives, which increased by 66%. This is a good thing, right? Everybody wants to become data-driven organizations because you wanted to stay on top of competition and be responsive to feedback from customers. At the same time, the survey also says that not everybody is able to successfully become data-driven organizations. So from 2018 to 21, 41% of the organizations failed become data-driven organizations, or they're not able to take it forward. Right? So these are interesting insights from New Wanted survey. So let's try to understand what are the measures that they may fail to do it. One of them is they failed creating a data-driven culture in organization. At the same time, they failed treating data as a business assets, and they're not able to compete on data and analytics. So these are the some context of how organizations are today with respect to investments in data space. Now, let's try to go to one step further and try to understand the failure symptoms. So basically, there are 4 failure symptoms why organizations fail to become data-driven organizations. One is fail to bootstrap. So these organizations have been investing too much time and money on technology-focused initiatives. They're not able to map their initiatives to the business use cases. That is one of the primary reasons. And secondly, they have been spending too much time on data lake or data warehouse design, and technology evaluations are not able to proceed further. or they have been working in silos. They're not able to provide end-to-end solution for the organizations to become data-driven. And the other failure symptom is fail to scale sources. As long as you have small number of sources where you collect data, transform and serve data, no problem. The more data sources that you need to process, then you are not able to scale and fail there. The other symptom is failure to scale consumers. Now you have data sets and you have consumers, but suddenly there is a huge increase in the number of people who consume your data. And if you are not able to respond timely and provide insights to them in timely fashion, then you fail there. Then the last thing is fail to materialize data-driven value, which means they have been spending too much money and effort on these initiatives, but they are not able to justify the business value and the cost that they have been put in. So, and fail to compete based on data and fail to change culture beyond pockets of R&D. So overall, these are the primary reasons or symptoms that we see in organizations which are not able to make further improvements on data-driven organizations. Now, over the period of time, there has been multiple generations of data platforms which are there to, which have been evolving to solve problems at that point of time. First, people have started with data warehouse, where they collect data from multiple sources and put it into central monolithic database called warehouse in canonical format, and people will consume from there, everybody. And typically in this model, they have been using a method called ETL. So you extract data from source systems, transform that data into canonical format, then load it into warehouse. So here they found problem where you cannot really convert everything into canonical format. That's one challenge, right? And also you do not have clear domain boundaries here. So they started move on to a next generation of the platform where data lake came into picture. So the typical difference between data warehouse and data lake here is instead of extracting, transforming and loading data, people started using ELT approach, which means we extract data from source systems and load data as is in raw format into data lake without any transformations, which means now it is consumer responsibility to read data from the data lake in raw format and transform it to based on their needs and store it in a place called data mart to suit their needs. This is how they evolved in the next generation. Now, from there, we moved on to third generation, which is current generation, where we moved on entire this data lake architecture into cloud, right? These are the three generations that we have been using from past 10 years or so in the big data space. Now, did it solve all our problems with the data? No, we still struggle to scale uh, needs of analytical data. So these are the uh, root causes among all the three generations that we have seen before. One is monolithic, no domain data boundaries. Whether you use data warehouse or lake or cloud, one thing that people have been missing is there are no clear domain data boundaries in that central monolithic architecture. Dump everything into one single big monolithic architecture. And it creates, it bloats the cost of infra and data maintenance cost. That was the primary reason. And second root cause was axis of change orthogonal to axis of architectural scale. Let's say you are building a data platform using data warehouse. You need to collect data from multiple sources. The first thing that you do is, okay, I need to ingest data, then I need to transform data, then I need to serve data, which means I have three steps. So you form three different teams based on the job that you need to do to collect data and transform and serve. And you form three different teams and they are not in sync. So typically what should have done is you should have formed teams based on the business capability or based on the features so that they work together, own end-to-end responsibility and deliver results as they needed. So this is one of the failure root cause. The third one is siloed data platform team, where there is a source domain team who knows everything about the domain. They work on operational data. End of the day, they dump their data into central monolithic architecture, where a group of hyper specialized data and ML platform engineers take the data, build this data platform, and make it data available for analysts and scientists. So here, the problem here is the people who is in the middle, hyper specialized data and ML engineers, they don't know anything about the domain context. Without knowing domain context, they try to serve data and prepare data. That is a problem, and they will not be able to address the complete needs of the users. The fourth one is missing links. So as I said, domain teams are the one who knows what it means about data that they have it and how to solve the needs of the consumers and what are the needs of the consumers. They know better. And if they pull the data from source systems and dump it into central structure and call it done, then at the consumer side, you miss that domain understanding and the intelligence that domain people will have it. So these are the failure root causes that we see most of the time why organizations are not able to become data-driven organizations and lose competition and market share. Now that we have set the context, what is the solution now? That's where data mesh comes into picture. So a definition is a socio-technical decentralized approach in managing and accessing analytical data at scale. So here I want to highlight two different things. First thing, it is a mechanism or approach for managing analytical data at scale, not for operational data. There are different architectural patterns to deal with the operational data. This is focused on managing and accessing analytical data at scale using decentralized approach. That is the first thing. Second thing, I have also highlighted socio-technical approach. The reason being, data mesh is not something, a tool or technology that you, if you just use it, you solve all problems with the data. It is a socio-technical approach, means you need support from people, you need transformation in organization structure, you need transformation in organization culture, and you need tools and technology to support all these transformations. You cannot do it without people and organization culture change. That's why both the socio-technical aspects and decentralization aspect are very important for data mesh. Now that we understand what is data mesh, let's try to understand what it means. So if you really want to implement data mesh, there are four principles or building blocks that you need to follow while building data mesh. First principle, domain-oriented decentralization, which means aligning your data to business domains and forming teams based on business domains, which means teams own entire business domain. There are no multiple people owning that data, multiple teams owning the data and transferring data between them. Second principle is data as a product. So let's say there is a sales team and they have the sales data. And what do they think of their sales data after operational data is being processed? It's just a data set for them. So data as a product principle says that do not think your data as a something output of your operational data. Think of the data set as a product, which will help you to democratize data understanding and make it discoverable in organization. Third principle is self-serve data infrastructure. It will help you to reduce the friction and increase the speed of productivity. The last principle is federated computational governance, which will help you to increase interoperability and make them trustworthiness while sharing data between the teams and domains in the organization. So I'll pause here for a second and see if you have any questions before getting further. Okay, I see no questions. So let's move on further. Let's try to dive deep into each of these principles and see what do they mean for data mesh and how to implement them using Google Cloud. So first thing, domain-oriented decentralization. In traditional systems, how we have been doing is there is an operational data plane and there is our analytical data plane, and we transform or we copy data from operational world to analytical data world using ETL pipelines. And there is a completely different team working on this analytical data plane. So there is no ownership of data between these two different planes. To solve this, what we do in this principle is we give the responsibility of domain data, whether it is operational or analytical, to one particular domain team, which means we converge the responsibilities of operational analytical data into one domain team. We'll start there. Now, break the monolith with domain-oriented domain data ownership. That's where we talked about converge these operational and analytical data worlds and make the domain team responsible for that. They want entire responsibility end to end from operational data to analytical data and serving the needs of the users. And domain teams wants both operational and analytical data. Domains are the first class concern. So earlier, we have been focusing more on the ETL pipelines as a first class concern. Now with this approach, your focus is more on domains, not on the ETL jobs. And domain data pipelines will become second class concerns within the domain. Now, architectural quantum shifts from pipeline to domain. So what is architectural quantum? Architectural quantum is about independently deploying your system with high cohesion and least dependency. So here you focus on deploying the entire domain as one particular architectural quantum, right? Rather than a pipeline. This is what is domain-oriented decentralization. And how do you implement in Google Cloud? So Google Cloud, you have a beautiful concept of projects. So you can create one project per domain or data product. That way you will be able to completely and clearly have a clearly defined boundaries between data products and domains, which will isolate and have clear separation between your products. So for example, in this example, you have a sales domain and you have two different data products in the domain. One is sales data, other one is sales predictions data. So a domain can have one or more data products, and each data product can be in multiple environments. You create one project for every environment, and that particular GCP project can have both data pipeline, orchestration, storage, and compute capabilities. So these is how you structure your clear responsibilities in the Google Cloud. Now, let's try and see the data as a product principle. What does it do? So in the first principle, we talked about domain thinking. Here we talk about product thinking. We consider domain data sets as a product, not just as a data table or data set. What do you mean by product? So the moment you think of it as a product, you think about your consumers. Do my consumers like my product or not? And how do I make sure I meet the needs of my consumers? And what more improvements that I need to do to improve the experience of my consumer? These are the things that you need to think about. So to think about all these things and to take care of the life cycle of a data product, you need a dedicated role. That is data product owner role. So who is working completely on data product life cycle to ensure that we are meeting the needs of the consumers. So that is about the data as a product principle. And if you go a little deep into it, this is how a data product looks like within the domain. So within the domain here, we have the boxes, two boxes, which represents that we have two data products here. And here, these arrows represents that they receive data through these ports, which are known as input ports. And they also share data outside the domain using output ports. They can be in different formats. It can be stream data, or it can be batch data, or it could be some other mechanism. But they have clearly defined input and output ports. They also have control ports, which will help you to manage the life cycle of data product using self-serve platform, which we will get into it very soon. And you cannot just call something as a data product. To be able to call something as a data product, you should have these attributes. The first one is discoverable. Your data product should be discoverable by the people in the organization, and it should be addressable. There should be a clear URL where you can navigate to and see how your data product looks like. And self-describing, which means you should not be able to talk to someone to understand what it is. There should be clear documentation which says what it is, who is the owner of it, and how the data can be used and what insights can be generated out of it. Trustworthy. So you should be able to trust your data product. So how do you trust your data? You expose some data which will show that you can be trusted. For example, you order something from Swiggy and it says that it will be delivered in 30 minutes. If it is delivered in less than 30 minutes or within 30 minutes, you trust Swiggy to order more from the platform, right? Similarly, you will define some service level objectives or SLAs for your product, saying that how frequently you update the data, what is the freshness of data, what is the quality of the data, right? When you export these attributes, people, consumers trust your data. So make sure you have the clearly defined SLAs for your data product. The next one is secure. You expose data using secure channels. Make sure data within the data product is properly protected. And only people who designated to access your data can access, and not everybody. Interoperable. That is the most important thing, right? When you have a lot of data products created, you also need to make sure that these products can exchange data between themselves, which means they should be interoperable. So if you build something which has all these qualities and it is architectural quantum, which means you will be able to independently deploy this data product with high cohesion and low loose coupling. That is when we call this as a data product, right? And for example, let's see a example from health insurance. Here we have call center claims data product, which is exposing data to output port. And we also have online claims domain, which is also exposing data through some output ports. We have two different data products now. Now we have a third data product, which is combining data from two different data products and calling it as a claims data product, which is aggregating call center and online claims. So we call this as a aggregated data product, and which is also exposing data again using two different output ports. Now, which can be extended again, which can be combined with member domain data, and we can create one more data product out of it, which is known as member interventions domain. So this is how you consider your data sets as a data product, and you ensure that you have clearly defined attributes. It is discoverable and interoperable, secure, and it is easily discoverable, all this stuff. So when you follow all these attributes and you have clearly exposed interfaces, we call this as a data product. And we have a dedicated persona to take care of life cycle of the product, right? So how do you build this data product in Google Cloud? So when we map these attributes to implementation, you need to make sure that you have a perfect data catalog, which is easy to identify what data sets you have and what kind of insights can you generate from, and the description of data set, and who is the owner of it, and what kind of sensitive data that it has. If you can expose all this metadata through data catalog, that is when you'll be able to democratize data and bring trust into your consumers. And you can use Google Data Catalog for this, but then if you are more worried about user experience, then you can use LinkedIn Data Hub as well, which is an open source implementation from LinkedIn, which will have a best user experience, which can build to expose metadata of your data products. And when it comes to trust, you can use service level objectives from Google Cloud, which you can build using cloud data monitoring custom metrics. And you can expose them again back into your data catalog, that is LinkedIn Data Hub, where you'll be able to gain trust from the customers using these metrics. And secure, how do you secure data? So if you are storing data in BigQuery, which is an analytical database in Google Cloud, you can use something called AEAD encryption to protect data or encrypt data in the Google Cloud. Let's say you are using multiple target systems to store your data, then you can use Tick library to encrypt data stored in multiple target systems. So this is how you can build data products in Google Cloud. And I'll be able to show a small demo using how to encrypt data as well throughout the end of the session. So I'll pause here for a bit and see if I have any questions. Okay, I see no questions. So let's move on to the third principle, which is self-serve data infrastructure. So when you have distributed the responsibility using domain teams and you introduce data product thinking, and every team needs to focus on building infrastructure for their own products. So study shows that teams are spending at least 40% of their time dealing with the infrastructure, managing, provisioning, all these things. So how do we solve this problem? By using platform thinking, we can build a shared self-serve platform which can be used to provision this required infrastructure automatically without any third person being involved. And the best thing here is people working on this building self-serve platform are completely domain agnostic. They don't know anything about the domain. They don't need to. All they need to know is how to provision infrastructure required for the data products. And this is basically owned by data infra and tooling team. And this abstracts away all the technical complexities of provisioning and dealing with the infrastructure using self-serve interfaces. And it enables domain teams to focus on business because they're able to reduce that 40% of effort which they have been spending on infrastructure management. Now they can focus on the providing business features for consumers. So let's see what are all the features that can be provided with the self-serve. So you have self-serve platform here, which is exposing some interfaces through provision infrastructure. It can be a Kafka topic or a bucket or a Spark processing or something else. So which can provide all these capabilities just with the click of a button, right? So this is how self-serve data infrastructure is implemented in data mesh. Now, how do you build this in Google Cloud? So first thing, if it is self-serve, you should be able to tell the platform what do you need. So you can have your own specification telling what all that you need. So for our example, we have been using this simple YAML specification, which will tell you what is the name of your data product, where you want to host it, who is the owner, what are the input ports that your data product have, and what are all the output ports through which you will be exposing your data, and who are consumers of data who will be able to access these interfaces. And do you have any workflow which is responsible for transforming data in this pipeline? So all this can be defined in a simple YAML or JSON specification. Once you have that, submit that to your platform, self-serve platform. And self-serve platform can be built in multiple ways, right? As I said, data mesh is just an approach or a concept. You can use any technology to implement. For example, I can use a simple CLI to build a self-serve platform, or I can use my own CI/CD technology to build a pipeline through which the self-serve can be provisioned. Or I can build a REST API implementation where you submit this spec as a post request, which will on the fly provision all this storage and processing power and architectural capabilities, orchestration capabilities required for your data product with the Google Cloud. So for our demo, we'll be using CLI to prove that technology is not important. It's the concept and approach, and the principles are more important in building data mesh. So I'll again pause here for a second, see if I have any questions. Okay, so I see no questions. So let's move on to the last principle of data mesh, which is federated computational governance. So most of the traditional systems use central governance mechanism in the organization, which means there is a central body which will kind of dictate what to do, what not to do in your domain teams. The problem with that is central team is dictating and mandating the rules to follow. And most of the time, domain teams don't understand why do we need to follow, what is the reason behind doing this. So they tend to not to follow. And they are not responsible for implementing and ensuring that they're complying to those rules as well. So what data mesh suggests is use federated governance, which means do not use a central body to dictate what needs to be done. Make all domain teams representative and responsible for this governance, which means there is a federated governance team, and every domain team will have a representation in the federated governance team. They have a say in defining what are all the rules, policies, and regulations to be made to make this data product interoperable and consistent across the organization. So anything with respect to global and interoperability, you make these decisions with the help of federated governance teams. But if there is very specific to your domain and the context, then you localize your decisions. You don't have to go back to federated governance team to make decisions which are related to your domain. That's why I say multi-level, multi-layered governance approach here. And now, as the domain teams are making the guidelines here, they own the responsibility here. It's not just somebody else is making rules for you. And domain teams will extend and enforce global policies by themselves now. They're responsible. And they focus on consistency and interoperability between data products to ensure that everybody follows certain guidelines to make it interoperable. And there is a middle word here, which is computational. What do you mean by that? So when you have defined these policies and regulations, how do you know that domain teams are following it? So we want to avoid manual intervention here. So what you do is you introduce computational governance and make these checks, audit checks automated in your pipelines, in every domain team pipelines. So these automated checks will check whether globally defined and agreed policies and regulations and compliance requirements have strictly been enforced at the data product level or not. That is how you implement federated computational governance in data mesh. So there is no central governance team here. Even governance is distributed with data mesh here. It looks like this. There is a data infra platform. There are a lot of data products which are provisioned using the platform. And there is a global governance and open standards defined by the federated team here, which are followed by all the data products. Now, how do you build this in Google Cloud? You have cloud IAM policies and group policies, which can define at the organization or project level, through which you can enforce certain kind of policies. And you can also enforce these policies in the pipeline as well through automated audit checks, like security, regulatory, and compliance checks to ensure that you are following proper GDPR guidelines and the sensitive data is being protected and you're using consistent data formats, right? This is how we use federated computational governance. Once you follow all these principles, that is when you have a data mesh implemented properly. And it looks like this over the period of time. You have a data mesh platform or data infra platform. which has clearly defined interfaces, which are used to provision info required for your data products. And one domain can have one or more data products, which are using capabilities from this platform. And they have certain attributes to make them data products, like discoverable, addressable, self-describing, secure, trustworthy, and interoperable. Right? So this is the high-level picture of the end-to-end data mesh implementation. And one thing that I wanted to call out explicitly is data mesh is not a simple transition. It is a journey, which means if somebody says, use my tool, you'll be able to implement data mesh, they are faking it. It's not, it doesn't work that way. As I said, it's a socio-technical approach, and it requires a lot of transformation and culture change and organization structure as well to be able to successfully implement data mesh. It's a multi-year effort, I would say. So do not think that just by bringing some tool, you'll be able to implement overnight. So just keep this in mind. It's a socio-technical approach and targeted at solving analytical data problems. So I see no questions again. So I will hand over to Bala for demonstrating self-serve platform built using Google Cloud Platform. So Bala, all over to you.
Thanks, Murli. Let's get into the action part. Hope you are able to see my screen. Okay. So we have actually built this data mesh CLI for provisioning the platform and as well as the data product, various different data products. For time being, we have already provisioned. So one of our a platform components, which is a data hub. So I'll start with a provisioning a simple a data product, which contains various input ports and output ports, as Murali mentioned. Let's start with a command called data mesh. Data product provision. So,
Hello, Bala.
so yeah, can you hear me?
Yeah, I can hear you. Just wanted to know if you guys want to take a 5-minute break before moving on, so that if anybody has any questions, they can ask. Or is that fine with you?
Sure, yeah.
Okay, cool. Then can have a break for 5 minutes. Then we'll just meet at 7:15. Is that fine with everybody? Okay, yeah. Sorry for
Yeah,
stopping you midway.
okay.
But yeah, we'll continue in 10:15, right? Okay, cool.
7:50.
Thank
We have
you.
10 minutes. Yeah.
Hello. I think maybe we'll you can share your screen, Bala, and then we can start. I think in 10 to 15 seconds. I think there are no questions, right? Yeah, I think we can just continue. Thank you.
Cool. Let's continue. So let's like initialize the data product like first. Data mesh, data product in it. So it says like the data product name has to be like specified as an argument. So I'm specifying like as a product. So let's take a retail domain as an example. We have like products in the retail domain. So I have initialized the data product called like a product. So you could see a folder has been like created like called like product. Let's see like what's in it. Right, we see like one data product at YAML file. This is a like pre-generated like spec to get started with. Like let's open it. Okay. So this is like so this is like a pre-generated like data product spec to get started with. So basically it helps you out like to kind of like understand like how do you like provision a data product. Like it needs a project, region and zone in which it has to like deploy it. And you see like the owners of this current data product, right? So who are all the owners? Like you can simply give an email ID and then like various input and output ports. Like you can it can support like a PubSub topic, or it could be a GCS bucket, or it can be like a BigQuery table. And finally, like we have like a workflow. So I'll come back to the workflow part like later. So what I did is like we have actually like already configured uh, a data product. So I'll actually like go through this spec like one more time to understand like a more. So basically here like we have in this section we have mentioned like what project these data products data product is going to be deployed, and its various like components, input ports and output ports, and who are all owners. I and like Murali, like we are like owners of this data product. And we have one input port called like a PubSub, like it's a PubSub topic basically, right? We have the queue name is like product created queue. And this can be like one of the domain events, right? You can have a number of domain events called like product created and updated, deleted. This is one such event like that. And we have output ports. Like output ports are like we have two output ports, like two different types of output ports. Like one is GCS and another one is BigQuery. So in the GCS, we are creating like two buckets, like a product purchase like a bucket and product bucket. And I have added like two consumers to these like buckets. At the same time, like we have like a two like different BigQuery tables, right? So one table is like a product fact table that has around like 6 different like fields, like what is the product name, ID, category, description, and all other fields. And we have like a product purchase like fact table. So who purchased this product and what is the payment method that you have used, something like that. And the workflow part, right? So this is actually a data pipeline. So basically what it does is it takes input ports and output ports as an argument. So it has the intelligence to understand like what kind of a data it's going to like read and write, right? And it simply like moves data from like a one source to another source. In the first example, what you see is like I have like we have configured like source connector called like PubSub, right? So and our like a sync connector is BigQuery. So then like I need like a more attributes, like what PubSub topic I need to like consume from, or what PubSub subscription I need, right? You see like one product created like Q subscription is available here. And also like what is my like a destination like a table that I'm going to like write to, right? Which is like a product fact. you see this like pops up subscription like will be created when we provision this like input port, pub support. At the same time, so this output ports also like will be configured. What does it mean? Before running this like before this workflow gets executed, all these like input ports and output ports will be like provisioned, right? So then once this like workflow starts, it starts consuming messages from the PubSub topic, and it writes the data to the like a BigQuery table, right? So this workflow is actually like is based on like Apache like a Beam. So data flow is one of the managed service offered by like Apache Beam. So offered by like a Google like GCP platform, and it's based on like Apache Beam. So basically like you can like provide like a different types of like spec templates. That's what we call like a data flow like templates. So by which like you will be able to like run like a different types of like pipeline. Currently we have already defined the data flow like a template. Basically we have written a code, just like it accepts any kind of like a source connector and the destination connector. Yeah, we have limited set of connectors, and it starts like moving the data like from and to these like connectors. So and vice versa, you will see like you see like one more like a data pipeline here. So now we have like a provision like made changes in this data product spec, right? So let us like provision data mesh data product provision. So okay, let's get into this like a product. Okay, we have data product spec file. Let us provision. So it takes like a few seconds to like create the resources. Okay, let's look at like our logs. Okay, it says like provisioning data product, and also like it says like created a bucket with the name that we have actually like specified in our like a template, that is like a product bucket 12 and a purchase product like a bucket 12. And also like it has created a table called like product fact, and also like a product like a purchase fact, and also it has created like a PubSub topic, right? Along with, so for every PubSub topic, like you need PubSub subscription to like consume it from, right? That is also like is automatically like a done. Let's wait for a few more seconds. Yeah, the subscription has been like created now. And so you see like two data flow jobs have been created: product created event pipeline, product purchase event like pipeline. So let's get into this like GCP console. Let me refresh. So we see like a product like a bucket. Okay, we see two different bucket, product bucket and product purchase like a bucket. Let us get into like one of these buckets. And let's see who has like what kind of like access like rights. You could see that like Murali and I, like we are like a bucket owner. So if you look at this spec, like we have mentioned like our email IDs as like owners of this like a bucket, or this like entire like this data product, whatever resources that are like being created by this like a data product, right? Which is part of this data product. So we are the owner of this like data product. And we see like we have couple of like a couple more like email, right? Yes, Rajan and yes, Santosh. And you could see they are like a bucket readers. Since they are consumer, like they don't have access rights like to like own this bucket or make any changes in it. Okay, so let me refresh this like PubSub topic. You could see like a one product created queue has been created. Let's check for subscriptions. The subscription has been like created for the specified like queue. And let's like refresh this like BigQuery. You could see that like there is one data set created called like partner master, and we have like two different like a product fact tables which have been like provision created. So finally it's our like time to like check our like a data flow job. So you could see like these data flow jobs which have been like started. One has executed in the batch mode, another one is like working in the stream mode. So basically like this like a data flow and Apache Beam framework has the like intelligence to understand about the source, right? So if it starts consuming from a queue, then like it starts in a streaming fashion. If it is a finite source like a file, or like it could be a GCS file, or it could be like a BigQuery table. Like in this case, like it runs in a batch mode, and we have the ability to change this like a mode of running this like a data flow jobs as well. So it takes like around like a 5 to 10 minutes to like to take this like data flow jobs to run. So in the meantime, like I'll hand over the demo to like Murali for a different topic.
Thank you, Bala.
Murali, it seems we have a question here. It's from Mahesh Hariharan. How are domain attributes applied to the product? What makes it full-fledged data product?
True. So we talked about multiple attributes, right? Discoverability and as one attribute, and secure, all those things, interoperable and all. So some of the things you will be able to implement using Google Cloud. For example, you make it secure by using the BigQuery encryption and decryption methodologies. So that is secure. And how do you make it interoperable? For example, just now Bala has been talking about using PubSub and Beam pipelines. So Beam is something which can support multiple different source formats and can process data and submit it. So which is interoperable. And how do you make this data product discoverable and people can reach out to and see what is a self-describing documentation is? That is something you enforce it by using data catalog, by implementing a data catalog. So which is something that Bala will be demonstrating soon after this. Let's hold on to that to see how that can be implemented. For now, as we are waiting for pipeline to come up, what we will do is we will see how data can be secured in BigQuery. Okay, so let's take a look at that. So now we will be talking about the encryption, decryption, crypto trading concepts in data mesh implementation. So first, what we will do is we will try to create the tables required for us, insert some data, then try to encrypt and decrypt data and see how we can do that, right? So for that purpose, what I'll do is I'll create a couple of tables here. So I'm creating customer key sets table, which will store customer ID and key set. So basically what I'm trying to do here is I'm trying to implement concept of crypto trading, which is something comes with the GDPR compliance, which means customers can choose their data to be deleted in your platform. So when you have data in multiple places, let's say you have data in Kafka, you have data in database, you have data in S3 bucket or cloud storage, how do you make sure you delete data related to customer in all these places? It's impossible, right? You can miss it out. So the best thing is you encrypt all the customer data with a key dedicated for that particular customer. And when customer says delete my data, you throw away that key. And as you do not have the key, you will not be able to decrypt any of the data that is related to customer from all the sources and targets. That is what is called as crypto shredding. So for that concept, I need one key per customer. So I'm creating one field here to store that key here. So you can think of key set here as something as keyring in your KMS in Google Cloud. So where you can create multiple keys within the key ring, right? So think of key set as a container for your keys, right? So it will be stored in this table as a serialized byte structure. Now that I have customer and key set mapping, I'll try to create one more table, which is the actual customer table, which can store all this data: customer ID, name, SSN, and city. Now I created two tables. For demo purpose, I'll create one more table, which is storing the encrypted data of the customer. So if you see, the difference is earlier we have name string, SSN string, and city string. Now I have as a byte representation, which is storing data in encrypted bytes data format. So now that I have all the tables required, let's add some data to customer table. So I'm adding some data here, basically two records with two different customer IDs, Murali and Bala. Just for demo, so I'm adding only two records. So we have inserted two records into the table. Let's try to create one key per customer for encryption of data rights. Here I'm using the AEAD functions from BigQuery, which will help you to create key sets, encrypt data, decrypt data, all that stuff on the fly in BigQuery itself. Within the BigQuery, you don't have to use any other tools to encrypt and decrypt data. So now I'll run this to create one key per customer and store it on the customer key sets table. Now I have plain data. Now I have one key per customer. Let's try to encrypt this data. So what I'll do is I'll use one more AEAD function, which is encrypt, to encrypt the data. This requires three parameters. One is the key set, the key that you want to use it to encrypt. Then what is the field that you want to encrypt? The last one is associative data. So this is used to ensure that you do not lose this data accidentally or replace it with other customer. For now, I'm not using associative data. I'm only using key set and the field that I want to encrypt. So it will take the key from the key set table, encrypt this field and insert into customer encrypted table, right? So let's try to run this. So it will just encrypt it and store it into encrypted table. Now let's see how does the data look like. Now we have data in the customer table, which is in the plain format. So it should be able to show you data in the plain text. You will not store like this in production. This is just for demo. Now let's query the encrypted table and see how it looks like. You will observe that all the sensitive data has been encrypted here. You will not see any plain text here. This is how you will be able to encrypt data using AEAD functions in the BigQuery. Now, how do I decrypt it? There are certain functions through which you can decrypt as well. So I'll show you that as well. So just like AEAD.encrypt, you have one more function which says AEAD.decrypt. For that, again, you need to access key set. So now I'll run this query to decrypt the data and show in the plain text. This is how you will be able to securely store data in the cloud and follow all the GDPR guidelines as well. Let's say you are not just storing data in the BigQuery, you are storing data in multiple targets and you still want to encrypt it. Then what you need to do is do this encryption in your data pipeline like Beam pipeline. So in BigQuery, behind the scenes, it is using Tink library for doing this encryption and decryption. You can use the same library within the Beam pipeline to encrypt data and write it to multiple targets as well. That way, all you need to do is delete key from the customer key set table. So we successfully implement crypto shredding concept. This is how we do crypto shredding following GDPR principles in Google Cloud. So I'll hand over back to Bala to continue the previous demonstration.
Thanks, Murli. Can you see my screen?
Yes.
Okay,
Yes, Bala, it's visible.
awesome. So the data flow jobs have started like running. Let's get into this, put some messages to this like a subscriptions, right? We have like this pops up like topic with us. Let us add some messages to the topic. So you can also like see the stages, various stages of like this data pipeline. The first part is actually read part. It says like element added equal to 11. Totally, we have sent like 1 plus 5 plus 5, 11 elements. So 11 messages that has been like a processed by this first stage. And then here it comes the windowing part, like it aggregates all the 60, like all the messages within like 60 seconds. And it actually writes to the next stage. So that is where the write part comes. So this write part, like it says like it has successfully written like 11 records. Let's like a query this like a product table. So you could see that all the 11 messages that we have actually like sent has been written to this like a product like fact table. So when we provision this a data product, right? It's not about like just creating like this data product, and as Murli said, it has to be like a discoverable, right? Discoverable. So that is like when this data hub like comes into like picture. So basically like this data hub like is nothing but it's a like a metadata like a platform where like you can add all the metadata about like your like various like data sets, and like who owns those like data sets, which team is part of it, and let's say what are all the fields that is does it like associated with, and what is a lineage, that is so where this particular data product has been like derived from. Let's say I have data product A and B and data product C, which is actually derived from data product A and B. You can visualize as a graph. And also like who owns this data, right? Let's explore like one of our data set, like call like a partner product master. So here like when I entered this when I get into this product fact, we could see like what is the schema of this like a product table, right? You could see this various fields and the respective descriptions, right? And also so like you can also see who are all the owners of this like data product. Here like as we mentioned in the spec, right, we have added myself and Murli's like email ID. It shows that like we are owner of this data product. And also what are all the different tags which are associated to it. So basically like this data set belongs to a product data product, and then it belongs to a product domain, right? That's like step one. So, and we can also like visualize the lineage. So it says this data set has like one downstream like a data set, right? So this product fact is a upstream like a data set of like a product like purchase. Product purchase needs a product like fact data set, right? And also like you can also like query this like a data sets and data products using the tags. For example, like I know I want to understand what are all the data sets which are offered by product team, right? So I enter product domain. I see there are two data sets which are like offered by the product domain. Similarly, let's search by a name. let's say I want to understand so what are the data set Balasubramanian like owns, right? We could also like see this, and also like you can attach like any number of like tags like to it, and it's not just like a limited like for like a BigQuery alone. For this example, like we have shown BigQuery, so you can also like bring in your data pipelines, and then like you can also bring in your like visualization dashboards, right? So at the end of the day, like to complete the end-to-end cycle, like you need some kind of reports which are being generated by the your team, right? So you want to, if you want to understand like who owns it, like who is the owner of it. So this data hub is a one central place where it offers like all your queries. Yeah. So that's like a pretty much from my side. So any questions?
Yeah, thanks, Bala. That is a pretty amazing demo. So, folks, feel free to ask any questions if you have. We can wait for some more time. And yeah, please.
Okay. So Murli and Bala, is it okay? Like, do you want to share some more thoughts or maybe some side decks about or further reads that they can do about this topic?
I think there is a lot of content from ThoughtWorks about the data mesh, so you can watch in the public forums as well. And if you're interested, there is also a meetup group called Data Mesh Learning, which you can subscribe to see how data mesh is being implemented by different organizations across the world. So those are the few things that I can suggest.
Uh, Murli, I think we have a question here about Murli and Bala. A self-service of infrastructure is done by the CLI.
Yeah,
Yes.
in this particular example, as I said, this is not about technology or tool. This is about a new concept that you want to implement. So you can do it however you want it, either through CLI or through a pipeline or through a REST API. You will be able to implement a self-serve platform and use the interfaces to provision infrastructure for you. But in this example, we have used CLI to demonstrate, but it's not something that you can do it only by CLI. You can use other ways as well.
Okay, for this example or like in this implementation, like we have used like Golang GCP like SDK to like a provision the data products and the infrastructure in GCP. Yeah.
Correct.
Yeah, great. Thanks, Murli and Bala. So, folks, feel free to ask any questions. We are coming to an extension. So, yeah, so I think we have one more question here from Mahesh. So,
Yeah.
are there any standards associated with data mesh, followed by the YAML grammar which was shown?
So with respect to any standards associated with the data mesh, I think the principles that we talked about are the guidelines for implementing data mesh. And YAML grammar, which is shown, it is just something that we have implemented. There is no open standard for the specification yet. So you are free to use which works for you, or you can use something that we demonstrated in the demo. So, but as of now, there is no open standard for product specification. We are working on it, and probably very soon we'll be able to do one more GeekNight talk about that.
Yeah, that's great. Yeah.
Maybe do you guys want to share your profile, like LinkedIn profile, or how they can reach you for further? Uh,
I
further.
think it was there in our first slide, I believe.
Yeah.
I think in two different slides.
Mm. We can share your LinkedIn links there so they can reach you out. Chat.
Sure.
No. Also, we have shared the feedback form in the chat, so we can you guys can put a feedback there. Well, I think Sumant, we can close it, right?
Yes. Yeah, I think it's almost 7:46. It's end of the day, and thanks everyone for joining, and thank you so much for Murli and Bala for giving a wonderful session and
Thank
making
you.
this happening. GeekNight 72 Hyderabad.
Thank you.